Hey everyone, and welcome. Think of this as your own personal training session, a geometry workout that's going to get you in perfect shape for that upcoming quiz. So, you've got a geometry quiz coming up? If that thought has you feeling even a little bit stressed, don't worry, you are in exactly the right place. We're going to tackle this head on, build up that confidence, and make sure you walk in there ready to crush it. Okay, so here's our game plan. It's simple, but trust me, it's incredibly effective. For each concept, we are going to solve an example problem together step by step. Then, we'll lock in the core rule behind it. And finally, I'll point you to the other problems where you can use that exact same skill. Ready? Let's get started. All right, first step, let's get warmed up. Our first set is all about mastering the coordinate plane. We're going to focus on how points move around, and we'll kick things off with a classic transformation, reflections. Here we go. Let's look at example problem number 2 from your sheet. We've got point A at the coordinates 4, 7. Our mission, to reflect it across that horizontal x-axis. So, where is it going to land? And this, right here, is the secret. It's a simple but really powerful rule. When you reflect across the x-axis, the original point, x, y, just becomes x, negative y. What does that mean? The x value stays exactly the same, and the y value, it just flips its sign. That's it. So, let's apply that rule to our point, 4, 7. Step 1. The x-coordinate, which is 4, doesn't change. It stays a 4. Simple enough. And step 2, we take that y-coordinate, the 7, and we flip it to its opposite. So positive 7 becomes negative 7.
And just like that, boom, we've got our answer. The new coordinates for the reflected point are 4, negative 7. See how easy that is once you know the rule?
All right, you've seen how it's done, you get the idea. Now it's time for you to put that knowledge into action. It's your turn. So, take a look at problems 3, 4, and 5 on your quiz sheet. They use the same method, just with slightly different rules. For number 3, reflecting across the y-axis, the rule is x, y becomes negative x, y. For number 4, across the line y equals x, they just swap places, so x, y becomes y, x. Just find the rule, apply it, and you are going to nail every single one. Okay, next set. We're moving on to one of the most famous, most useful tools in all of math, the Pythagorean theorem. We'll be using it to find those missing sides of right triangles.
Okay, here's our example, problem number 6. We have a right triangle, and we know the two shorter sides, we call those the legs, are 6 centimeters and 8 centimeters. We just need to find the length of the longest side, the hypotenuse.
And the key to this whole thing is, of course, the Pythagorean theorem. A squared plus b squared equals c squared. Remember, a and b are the legs, the sides we already know, and c is that hypotenuse we're looking for. So our first step is super straightforward. We just plug in the numbers that we have. We'll substitute 6 for a and 8 for b. And now our equation reads 6 squared plus 8 squared equals c squared. Okay, now for the fun part. Let's solve it. 6 squared is 36. 8 squared is 64. Add those two together, and you get a nice, perfect 100. So we know that 100 equals c squared. But hold on, we're not quite finished. We're looking for c, not c squared. So we just take the square root of 100, and that is 10. The length of the hypotenuse is 10 centimeters. Done. Okay, you've seen the theorem in action. Not too bad, right? Now you know the drill. It's your turn to apply it. So check out problems 7 and 8. For number 7, there's a small twist. You need to find a missing leg, not the hypotenuse. So you'll just rearrange the formula a little bit. A squared equals c squared minus b squared. And for number 8, just remember that a diagonal cuts a square into 2 perfect right triangles. You've totally got this. All right, time for our final workout set. And for this one, we are scaling things up, literally. We're going to be looking at similar figures and using the power of proportions to solve some really cool problems. Let's dive into problem 14. This is a classic shadow problem. A student who's 6 feet tall casts an 8-foot shadow. At the very same time, a tree nearby casts a 30-foot shadow. So the big question is, how tall is the tree? The secret here is realizing the student and the tree create similar triangles with their shadows. Now, the absolute best way to tackle this is to get organized. Let's set up a proportion comparing the height to the shadow for both the student and the tree. So the student's height over the student's shadow has to equal the tree's height, which we'll call x, over the tree's shadow. Now we just have to solve it. 6 over 8 equals x over 30. We do that cool cross multiplication thing. 8 times x equals 6 times 30, which is 180. Then just divide 180 by 8, and we find that x, the height of our tree, is 22.5 feet.
And there you have it. You've just mastered proportions. So let's put that new skill to the test on the final problems.
Okay, I want you to apply this idea to problems 13 and 15. But listen up, because these problems introduce a crucial new layer. We're talking about scaling area and volume now, and you absolutely have to remember this key rule. If you scale a shape's length by a certain factor, its area scales by that factor squared, and its volume scales by that factor cubed. That is a critical detail, so pay close attention.
And that's our workout for today. Seriously, excellent work. Before you head out, let's do a quick cool down and go over your final game plan. These are the key formulas you need to have locked in.
Here is your ultimate cheat sheet. For an x-axis reflection, it's x comma negative y. For right triangles, a squared plus b squared equals c squared. For similar figures, you just set up a proportion. And please don't forget, when you're scaling, area scales by the factor squared and volume scales by the factor cubed. Look, you've done the work, you've practiced the methods, you have mastered these rules. So my final question for you is this. Geometry isn't just for a quiz, you know? It's the language that we use to design and build literally everything around us. So where are you going to use these rules to build your world? Good luck on the quiz. You are ready.